Okay. Now I have opened up all the three PDFs, all the both. I mean, the paper one, paper two, and the paper two examination report and mark skin. All of them we have open. So we'll dive right into paper question number paper two, which we are gonna try and solve for today for the problems that the kids have. এটা তো তোমার পড়ানো ছিল না, পড়ানো হচ্ছে ইয়েতে লাইট চ্যাপ্টারে। লাইট চ্যাপ্টার হচ্ছে অনেক শেষে। So I might pull this backwards by a huge amount.
স্যার আমার একটু সাউন্ডেও প্রবলেম ছিল স্যার 2D আর C
Mm. 2D. Okay. We'll go ahead and explain 2D over here. Have a look at question. This question reads: Figure experiment shows how the ultrasound is used to produce image of the heart. Why they have to go ahead and use an ultrasound? They could have used some good passionate singer or musicians. They see the heart every single time. Anyway, jokes apart, Fixed one shows that ultrasound used to produce an image of the heart. Define ultrasound. Ultrasound has wavelength of this much. The speed of ultrasound in human body is this much. Calculate the frequency of the sound. So you have to use V equals to F lambda. Ultrasound is like the longitudinal wave describe how particles in body as the ultrasound passes. Image diagram in your wish. Acha, it was simple. You have to just represent the whole idea of forward and backward movement of the gas part of the medium particle. So you have to say the forward and backward movement of the human body molecules is basically the responsible for the transfer of ultrasound waves from one place to another place. However, that was not the question. The question that I did receive was from question number D, which reads: there are small bubbles of gas in the body.
So the question was both C and D.
All right. Question number D দেখো তারপর সিনেমা বলতেছি পরে। As I was saying, the question number D says there are small gas bubbles in the body. Explain why these gas bubbles will expand and contract in the and contract as the ultrasound passes. All right, try to understand. I mean, essentially, what does it mean? I mean, how does the longitudinal wave travels from one place to another place? It produces a series of compressions and rarefactions within the medium. So if you have a air molecule, actual air solid air molecule present within a certain small section, and let's say after that point, after the I mean in the sound that you're trying to create, after a little while, the two objects become start to have the I mean after some time, let's say the object that we are working with, let's say that can process the sound pretty well, but that is not going to be equal for all the different objects made from the same material. The reason is very simple, because how far the object can or how many of the objects can actually be settled, do we have a specific limit for that? So that's one thing. And the question says explain why the gas bubbles expand and contract as ultrasound passes. Because physically the process by which ultrasound passes is by expanding and squishing the medium particles. So whenever that expanded region will actually pass the wave, actually pass that region of the sky, then it's going to be represented as a null signal into our brain. So our brain can choose to represent 0 over here to represent null, or we can also try it like this. So yeah, that's that. So the gist idea of this question is that uh, every object has intermolecular spacing for loads. Even with loads, this is also equally true. এই and then বাকি যেগুলো আছে সেগুলো হচ্ছে বেসিক কথাবার্তা যেগুলো আমি নরমালি বলছি। সো এটা গেল
স্যার
হচ্ছে
আমার মনে হচ্ছে আচ্ছা
বলো।
আমি ঠিক শুনতে পাচ্ছি না স্যার, একটু আবার একটু রিপিট করবেন স্যার।
আচ্ছা হ্যাঁ প্রবলেমটা বলো।
স্যার
হ্যালো হ্যাঁ বলো বলো শুনতেছি আমি।
আমার একটু ইন্টারনেটে ল্যাগ করছে স্যার, একটু আরেকবার বলতে পারবেন স্যার প্লিজ স্যার? সরি স্যার, একবার ক্যান্সেল হয়ে গেছে, বের হয়ে গেছে মিটিং থেকে, সরি স্যার।
The key idea for question number D is that the sound produces a series of high pressure and low pressure or compression or rarefaction regions. So whenever the ultrasound will pass through the medium, the intermolecular spacing of those particles will also change. However, for spreading particles, for if the wave is spreading up, then we're gonna have the frequency lowered, and if we have multiple waves to get stronger compared to each other, then the wave can go higher. But that's the additional information. You don't essentially have to be able to or have to remember to write it in your answer choice. You don't. বুঝেছে?
স্যার লাস্ট কথাটা কি বলেন যে আই ডোন্ট হ্যাভ আ চয়েস লাইক দ্যাট?
কোথায়?
স্যার আপনি বলেছিলেন যে আই ডোন্ট হ্যাভ আ চয়েস বলছিলেন, এটা কি স্যার?
Yes, I said that. Yeah. বলো এখন প্রবলেম কোথায়?
I mean, I wasn't able to understand how shall I mean, write this answer.
How the different frequency of light is occurring?
I mean, we are supposed to describe how particles in the body move as the ultrasound passes. I mean,
Yes.
am I supposed? I'm definitely supposed to write in the atomic level, but what I want step by step. How can I write it? I was confused.
Hmm. Your writing is perfectly good. So I just added one single point that whenever you, I mean, you specify the two different state of the atmosphere, like expanded, where you have a larger intermolecular space, and alternately squashed, or where you have lower intermolecular space, or the compression. So you define the low pressure region and the high pressure region as individually for their own values at this time frame. They don't exactly need to be exactly correct.
Okay, sir. Meaning the particle, the our sir, shall we say molecules or cells, or just simply
You can say human body particles. Particles is a word that can cover both the regime of atoms and molecules together or individually. So you can use the word particle in place of atoms or in places of molecules as well. That's easily applicable.
so we will say that the human body particles, they are pushed at certain region, causing a form of gap and uh, and constant and a concentrated area at another region, thus making a some longitudinal wave.
Now, what I mean, two question একবার বলো what is your what is it that you're trying to achieve?
I mean, I'm planning, I'm trying to figure out how to write this answer in a step-by-step processor.
Okay, এইটা আনসারটা আর বলো।
Oh, answer to sir. Um, due to the longitudinal wave of the sound in the human body, in some regions, once the particles are pushed and concentrated, and in other regions they are small tiny gaps are formed. The concentrated regions are the compressions, and the gaps are called rarefactions. এরকম এরকম হয় না স্যার?
Now that's a pretty large answer for 1 mark, but it actually essentially covers the point that is required for this answer. So your answer to your simple answer হয় কি হয় না is yes হয়. Is it enough? It is actually largely redundant. So you have তুমি এমন অনেক জিনিস করে লিখছো যেগুলো অ্যাকচুয়ালি আমাদের কোশ্চেনে চায় নাই।
স্যার খালি এটা বলা যায় না যে as the alternate series of compressions and rarefactions produced by the ultrasound passes its bubbles, they contract when the compression passes due to high pressure and expand when rarefaction passes due to low pressure on the bubbles. হয়
জাস্ট প্রেসার ডিফারেন্স বললেই তো হয়ে যায়, প্রেসার ডিক্রিজেস ইনক্রিজেস, আর কি বলার আছে?
ইয়েস স্যার, প্রেসার ডিফারেন্স বললেই হয় না?
তুমি প্রেসার ডিফারেন্স দিয়ে বললেও হবে, যেহেতু এখানে 1 মার্ক আছে, সো এখানে প্রেসার ডিফারেন্স দিয়ে বললেও হওয়ার কথা। বাট যদি if there are more marks to this thing, then you would have to talk about the actual intermolecular spacing between the particles of the human body. You would have to cover that information as well. For 1 mark, you can essentially talk about high pressure and low pressure difference and etc. Go ahead.
কিন্তু যদি আরো মার্ক থাকতো তাহলে বলতে হতো যে as the rarefaction passes the molecules come further apart and as the compression passes the molecules come closer together creating high pressure making it contract. Understood sir, thanks.
So
প্রেসার কেন আনতেছি? লংগিটিউডাল আপনার রেয়ারফ্যাকশনস আর কম্প্রেশনস নিয়ে বললে হয় না শুধু?
well, basically compressions are the high pressure regions where multiple layers of the medium or multiple vertical layers of the medium, they get squashed together. That's what we mean by compression. Compression is the location where you have a high pressure region where the energy is clumped together, and rarefaction is a low pressure region where the energies can easily dissipate out. So you can alternately use the word let's say high dense to now. Also, sorry, you can alternately use the word, let's say, compression and rarefaction for a longitudinal wave with compression is with high pressure and low pressure regions. So you can use those terms.
ওকে স্যার।
আচ্ছা, বলুন সি নাম্বার বুঝে গেছে?
ইয়েস স্যার।
Yes sir.
আচ্ছা, ঠিক আছে। তারপর নাম্বার 3 থেকে আর কোনো প্রবলেম?
সিআরও কি আপনি পরে বুঝাবেন নাকি?
আজকে মানে সিআরও বোঝানোর প্ল্যান ছিল, রাইট?
জানেন ভালো।
In one of our last classes, I believe I discussed the wow. Thank you. In one of our last classes, I believe I discussed the I discussed the structure of the CRO. Am I correct?
ইয়েস স্যার। ইয়েস স্যার।
কিন্তু পুরোপুরি করি নাই, আপনি একটা অংশ নেক্সট ক্লাসের জন্য রেখে দিয়েছিলেন।
So I want to discuss it with you about how the calculation of CRO is done. Okay, yeah. So I would like to continue with that. CRO part গুলা eventually পরে বুঝা লাগবে, so একসময় পড়ালে হয় ব্যাপার না। Since I'm having video lectures, so I am able to copy it all together, and that helps a lot. Yes. CRO স্কেলিং কিভাবে হয় সেটা বোঝার জন্য আমি তোমাদেরকে বেসিক CRO ফিগারটা দেখাই। আচ্ছা, this is a very basic view for how a CRO could look like. So আরে মাউস ঠিক মতন জায়গায় নিতে এত কষ্ট কেন? এই, all right.
তো স্যার
বলো।
আপনাকে যে ইউটিউবে যে কপিরাইট ক্লেমস মারে যে আপনি ওর নিচে আপনি যে সব ভিডিও দিচ্ছেন ওগুলোর নিচে লিংক দিয়ে দিলে হয় না আপনার ভিডিও ডেসক্রিপশনে?
ওটাই করতেছি এখন। মানে কত মিনিট মার্কে কোন ভিডিওটা অ্যাপ্লিকেবল হবে ওটা ডেসক্রিপশনে লিখে দিতেছি।
স্যার কাজটা একটু ভেজাইলে হয়ে যায় না তাহলে?
Well, if I have to teach kids like you, what else option do I have? But you are correct, Bipro.
আচ্ছা স্যার,
নোটস গুলো কই?
নজরুল্লাহ পিপরা নিয়ে গেছে।
বিপ্রো
আছে
এই নোটস গুলো গ্রুপে ফরওয়ার্ড করে দিও।
ওই যে বিশাল বড় নোটস গুলা? হ্যাঁ দিবনে।
কিসের নোটস?
বুঝবো না।
বিপদ
I guess.
কিসের নোটস?
এগুলো অ্যাকচুয়ালি অনেক বেশি ডিটেল, তোমাদের এত বেশি ডিটেলস লাগবে না। I would like to find out one figure where CRO is actually given to the level of detail that you will record this. Let me find that out.
স্যার ওগুলো কি আমাদের বই আছে?
হ্যাঁ, বই হাতে কাছে রাখো, বই একটু পর লাগবে।
এক মিনিট। এই যে স্যার একদম হাতের উপরে এখন কাছে।
না, এখানে নাই।
Please don't cry, sir. এটা কি? এটা কি?
আর জায়গা আছে খুঁজলে পাওয়া যাবে, সেগুলো হচ্ছে 4। Exactly. This is a functional view for how the CRO face or the interface of the CRO device should look like, that you should be able to analyze for your syllabus volume. Have a look. When you are looking from the face of the CRO into the CRO or towards the CRO, which means this is going to be working as your oscilloscope. This is the output view of the fluorescent screen. Which fluorescent screen? Let me help you remember. I'm going to have to copy this. Yes.
Sir, কি খাচ্ছেন?
Shiara.
Oh wow, ভালো তো। I'm eating cake, sir.
ইনকে ফিয়ার সবগুলো এত কমপ্লিকেট করে দেওয়া কেন? অসহ্য।
Life is full of complications, sir.
That's true. That's true. This will do one job.
Sir, কিছু
Ouch.
All right, got it. So let me explain and elaborate this idea. This is the basic structure inside the CRO. So this part is, this part is what we call this part is called the electron gun. This part is defined as the deflecting plates, and this part is a single part which is called the fluorescent screen. Now the purpose of the fluorescent screen is to make Yusuf, you are not. Are you asking me questions?
আরেক কোচিং আছে মনে হচ্ছে
Activation level.
স্যামের কোচিং আছে
মাল্টিটাস্কিং
What is happening?
পয়সা স্যারে ক্লাস করতেছে হবে
হ্যাঁ স্যার বাদ দিন।
Acha, never mind. So the purpose of the fluorescent screen is to enable us to view the exact location where this electron beam is going to come and hit. Now, what I wanted to understand, this device is physically looking like a pretty long light, like floodlights or something like that, or like a like the old torch lights that people used to have. You have a long battery space, and then you have a butty kind of or a bowl kind of inverted bowl kind of shape, which is gonna be used as a reflector, something like that, where all of the inside locations are empty or evacuated chamber, since the electrons can move freely and they don't get absorbed by the atmosphere. If the atmosphere is to be present, that it wouldn't be possible for this a cathode oscilloscope to work. So purpose of the fluorescent screen is to produce a small glow at the location where the electrons come and hit. It converts the kinetic energy of the electrons into visible light for our eyes. Now, the way fluorescence work is that it will glow immediately, but the glow will last for a slight time. The glow is not going to be. I mean, the way fluorescence screens work is that their glow behavior is that if one location starts glowing due to the energy supply, then that glow going off happens gradually, or it dies out. Any location on a fluorescent screen simply never blinks. Now, this is a very important idea, because the way the CRO works is that it always produces one single fine beam of electron. Always. But whenever we will actually move the but on the CRO screen, I mean, when you are looking from here, I mean, so when you are looking from here, আমি খুব normally কথা বলতেছেন, all of my devices are working perfectly.
আচ্ছা স্যার, এখন শোনা যাচ্ছে।
So keep your eyes peeled and sit close to the router. So when you're looking at the stereo screen from a position like this, let's say this is our eye, and this is our head, and yeah. So if you are looking from this part, we are looking at the stereo spot. We can make for our eyes to view the entire image that looks like a shape like this. This does not happen because the electron beam shoots at all of these positions to produce a line like this. Rather, the electron beam shoots electrons along this very specific line, which we can see. We'll see in a bit how we can control the shape of this line. For appropriate settings over here, the electron beam shoots itself along this line and covers the entire screen. Once it is done covering the entire screen, it then jumps back to the starting point and does the same thing once again. Now, this entire coverage of one beam is usually so strong. It is so strong, and it usually is so fast that by the time the electron beam finishes, is glowing with the end. At the end of the oscilloscope, the first point has almost lost no part of its illumination, which means whenever we make the beam look like a line or it looks like as if it was a curve, the electron beam does not hit at all the possible locations at the same time. Rather, it hits different part of that beam at different times, but it comes back to the same point with such a high frequency that the earlier glow that the fluorescent screen was having from receiving the earlier electron, that is minimal compared to the later one. So it's basically, or in other words, if I have to physically put it this way, I can put it. I can help you understand it this way. Let's say you have a garden hose which is shooting out water at a really high speed, and you're gonna move it really fast. So if you move it really fast, you will not be producing entire manipulate. So you'll be making the water particles or the water stream will come out according to a very specific or a line or orientation as you move your garden hose. So that's something like this over here as well. So no matter how complicated of a figure we do see in a cathode oscilloscope, they are always, and I mean always, produced by some sort of stretch paper. Sorry, not stretch. I mean, the way we can see this entire large figure is by moving the electron beam so fast so that the earlier points doesn't even uh, lose their illumination altogether. এই পার্টটুকু বুঝা যাচ্ছে কিনা?
happens so fast that the
Yes, sir.
earlier spot has no time to lose its illumination before it is re-illuminated by the shooting electrons.
Yes.
And the
Yes.
screen is fluorescent. That means when the electron strikes it, it releases some light energy, right?
Well, it's not it's essentially that simple. One of the ways that you should write, which we appreciate, is that when the electron hits the fluorescent surface, its K converts to light energy.
Oh, okay. When the electron hits the fluorescent surface converts the electron's kinetic energy into light energy.
Yes. So that can be a functional expression. So এই জিনিসটা হচ্ছে how I mean, what do you see on the top side? Now comes the question: how can we possibly achieve such a beautiful sine curve in our CRO? Now, for that thing, we have to look at a couple of things. Have a look. Have a look at this figure over here. This one on the left figure. You can see that this is how the face of the CR looks like. So this is a much more simplified version of what I was trying to search over here a bit earlier. There are a lot of CR faces, but I said that these are too complicated for your understanding. Remember? Anyone?
Yes, sir. Yes, sir.
So এখানে না যে ব্রাউজারে ছিল যে এই প্রবলেমটা। ব্রাউজার কই আমার? To zoom. So for example, if I consider AJ, for example, if I consider this specific view, I mean, it is actually the theoretical front view of the cathode oscilloscope, but practically there are too many information to be input. So I do not want to show you so many information because it is already much enough information already. So the way we achieve magnetism, the way we can make so different parts of this whole thing. Why is my PC acting up? Or I forgot stuff maybe. The first you're gonna see the cathode oscilloscope body. So this is the cathode oscilloscope body, and then on the right side we have some circuit, which are basically power circuit or yes or no kind of circuit. Will the machine work or will the machine not work? That kind of a thing. So we have on or off switch. You do understand what is the purpose of that? It gets silly. I mean, that's the power switch. Then we have focus and intensity. Did we discuss about focus and intensity in our earlier class? The last class that we have had on CRO.
No.
Yes. Acha. Let me tell you about focus and intensity. Focus is about how big will be the thickness of this line. Try to understand. This electron beam is coming out, and essentially this anode that we have over here, I told you in a discussion part, this anode definitely has a small opening, right? Through which a very small fraction of all the electrons which are pulled by the electric field, all those electrons are going to start moving out of the anode, and they're going to start their journey to give you this graph. Now, important part for you to understand, right? Really important for you to understand that all the different particles that we are working with, all the different all the electrons that we are working with inside the CRO, these electrons are coming out through a very small tiny hole that exists at the center of the anode, which means because that thing has a certain dimension, because it cannot be of zero dimension, out of the question, because that thing has some value of dimension, which means that electron beam can also move by a certain amount. Whenever we operate with the focus, this will somehow, through some internal technology, we don't have to cover that in our syllabus. So whenever we operate the focus, we somehow can choose, is the electron beam, when it is gonna hit onto the fluorescent screen right over here, as it hits the fluorescent screen, what will, how will that thing, how will that uh, 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 contact point of that electron beam is gonna be? Is it gonna be a very large circle kind of contact point, or is it gonna be very sharp, almost like a dot kind of contact point? So
Sir, sir, এভাবে বলতে পারি না যে the focus influences the size of that small hole in that plate through which the electrons pass through?
no,
That note.
no, we cannot. বলতেছি। So we can say, however, what we can, I mean, focus does not control the size of the anode. Focus is controlled by focus controls the thickness of this line. Because to understand, this line was actually created by moving that small dot that you would get at the center of your graph, provided nothing, every input into the CRO was 0. If every input to the CRO machine is 0, then essentially we'll have the electron beam hitting at the dead center of the CRO device. So if you have that, then you should get a single dot and nothing else. That single dot, if you start to move the single dot around, then it will immediately start to get covered into what?
The curve.
Into a line, into a curve, exactly, into a curve or into a straight line. It can be a lot of different shapes that we can achieve and work with. So the focus basically works with the thickness of this line or the size of that dot, if it's a dot only. That's the part of the focus. What works for the intensity? Intensity is about how bright that trace is. I mean, whenever you have this trace produced in your CRO screen, in appropriate cases, you might actually want to increase the brightness of your view without actually hampering or changing the whole process. So what is really important for us to understand, that how can we actually work with the intensity and how can we work with the focus? The focusing mechanisms actually require a lot, quite a good number of optical equipment help. So focus was not very highly discussed in our syllabus, but we have the idea of intensity. Intensity is about how, I mean, intensity is about brightness and focus is about size. Well, acha, intensity is about the brightness of the trace. Yeah, this curved line is what we call the trace in many cases. So terminologies we should get used to. So intensity works with the brightness of the trace, whereas focus works with the thickness of the trace. Now, how can we possibly control the intensity of the device from this thing? Let's have a look over here. I have a look at this figure and try to figure out that controlling which voltage might actually affect the intensity without affecting the shape of the graph.
Sir, V1.
Okay. One of your friends' response was V1. How about the rest of you?
V3.
Sir, I think I changed to V2.
Sir, V2.
V2.
Okay.
Sir, V2 হবে।
V3 কেন হবে না?
Okay.
Sir, V1 can increase intensity.
Okay.
Sir, V1 বা V2 যে কোনো একটা হতে পারে। Maybe
Yes,
both.
maybe both of them, but not V3 and V4.
আচ্ছা, hold on, আমি তোমাকে জিনিসটা বুঝাই, ঠিক আছে? Just a quick recap from our construction class. What I really want you to appreciate is that V1 is responsible to heat up its own self. The voltage V1 controls the temperature of your coil, which controls the number of thermionic emissions per second. If you maintain the heat cathode coil at a much higher temperature, you're going to have more thermionic emissions compared to otherwise. So it is that glucose value, it is that voltage which practically controls how many electrons are going to come out. That's point number one. As the electrons are produced around the cathode, have a look. Do you guys, please respond. Do you guys know which part in this figure am I referring to as cathode?
Yes, sir.
B1,
Yes,
sorry.
sir, coil হচ্ছে cathode and the rectangular thing is the anode.
Exactly. The coil is named over
Rectangular
here
thing
as
is
cathode,
no?
and the open rectangle, or I can say the
Yes, open rectangle.
90-degree rotated U, that should be the anode. Achha, anyway, moving on. So the purpose of the V1 is to maintain the temperature of the coil. Higher voltage will give you more heating or more temperature or more thermionic emission, which means more electrons per second, important effect, and lower and vice versa. And also the V2 over here represents the accelerating voltage. Accelerating voltage means once the electrons will be produced from that coil, they would have nowhere to go. So to make them all move in a single direction, we're going to set up the anode, and the anode is going to operate at a very high, very high value of positive voltage. So you know all this stuff. Now, if we have a low value of V2, please try to understand. This is why it gets interesting. If you apply a low value of intestine, did I say intestine?
Yes, sir.
But intestine is not involved here.
স্যার একটু
My bad.
নেট সমস্যা ছিল তো শুনতে পারিনি, একটু আবার বলবেন স্যার।
আচ্ছা, আমি একটু ভিডিও আপলোড করে দিয়েছি, নো প্রবলেম। সো এখানে জিনিসটা হবে যে if the value of the V2 is said to be high, or if you have a larger value of voltage of V2, then that would cause the electrons to accelerate out to a very higher value. What you need to understand, I mean, the way I can put this thing, that the electric field that we have between the coil and cathode and the anode, which means the coil and the rectangle, open rectangle, the electrostatic attraction force that we have over here is going to be responsible for the electrons to journey from the cathode to the anode location. Now, as this journey happens, they are gonna speed up because they are gonna be continuously pushed by the negatively charged cathode, and they're gonna be continuously be pulled by the positively charged anode. So they're gonna experience a force really strongly. So if we increase the voltage V2 value, then the electric field will become stronger. As a result, that force of attraction will also become stronger. And stronger attraction will essentially produce much significantly stronger, much more significantly stronger. What?
Acceleration.
Much more significantly stronger acceleration. Okay, acceleration. Fine, let's go with that.
মানে স্যার
And which will cause the electrons which will be coming out of the electron gun to have a much higher speed. So and vice versa. So what I'm trying to mean over here, that V2 controls the output speed of the electrons, whereas V1 controls the number of electrons produced per second. এই দুটা জিনিস ক্লিয়ারলি বোঝা গেছে?
Sir.
Understood.
আরেকবার বলতেছি, স্টেটমেন্টটা খেয়াল করো সবাই। V2 controls at which speed the electrons will hit the ইসু, তোমার চ্যানেলটা পার্সোনালি মিউট করো। If you want to talk to, you will unmute it yourself, and then please go talk to the channel.
সবাই
তোমার চ্যানেল থেকে ব্যাকগ্রাউন্ড নয়েজ আসে একটু পর পর। Please be careful about this. I appreciate it. So V2 is responsible to control the output speed of the electrons, whereas V1 is responsible for how many electrons are produced every second or in unit time. So এই পার্টটুকু তো বুঝছো সবাই?
Yes, sir.
So the way intensity is important is that intensity is about how much kinetic energy can you actually transfer on a single location of the screen. Now kinetic energy formula হচ্ছে K equals to half mv square. Kinetic energy formula হচ্ছে K equals to half mv square, which means in the process of kinetic energy we do have mass, which is half mv, half m, and then v square can be worked with, or it is dealt with. Should I say dealt with? Yes, dealt with. Yeah, whereas v square can be dealt with, the which the speed square can be dealt with by controlling the accelerating voltage, which is called the v2. So this is what we call the heating voltage v1, and this is what we call the accelerating voltage v2. So they have individually different purposes. Now here comes the idea. So so the point where I actually where I started this discussion was from the right side figure, is that if we the question ever asks us that what is the purpose of the intensity button, you're only going to mention that the intensity button causes the trace to become more intensive, or you can say that this one controls the brightness of the trace that is seen on the CRO. Now, if you wonder that why is that even necessary, the idea of necessity is pretty simple. I mean, for those of you who have ever used used any of the smartphones, Android phone or Apple phone, you know the purpose. You know why do we require that brightness level adjustment thing? If you are using it indoor, you need one type of illumination. The moment you walk outside on a sunny day, your mobile apparently is not working anymore. Do I make sense?
Yes, sir.
So for those of you who know this experience, you know what I'm saying. For those of you who do not know this experience, you will eventually experience this in your life. So what I mean is that to control the intensity, we have access. I mean, we can choose to control both M and V as well. Now, typically speaking, for a CRO, the way CRO works, it can have individual inputs from the for the CRO, so cathode ray oscilloscope. So your input component can give you one of the output. If we are trying to increase the value of half mv square, one logical choice might be increased to increase the m factor or mass factor. So, but that is something that we cannot manipulate because the mass of a single electron is practically fixed. So what we are only left with is the v square. Now, v square is the speed. Which of these in this figure? In this one, oops. So in this figure, in this right figure, which of these voltages do you think can actually physically affect the speed of the electrons?
Sir, V2.
Sir, V2.
V2, sir.
It is supposed to be V2. So, so typically intensity is controlled exclusively by the voltage difference or V2 minus V1 or something like that. So that is just to remind you of the whole situation. এখন আমরা একটা জিনিস খেয়াল করি, সেটা হচ্ছে this is how the whole beam is gonna move. And then we have also seen the idea about the sawtooth voltage in earlier class. Let's try and solve some idea about how the graph works and why the graph looks like that. So turn up your federal book on the page where the CRO table is located.
383.
Although
383.
Thank you. Got it. So প্রমাণ এই জিনিসটা একটু বুঝো, তারপর আমি তোমাদেরকে আরো কিছু এক্সাম্পল ওয়ার্কশিট থেকে দেখাবো, ডোন্ট ওয়ারি।
The time base মানে
CRO এর the two axes, x-axis and y-axis for a CRO has two exclusive names. The vertical axis is called the Y gain and the horizontal axis is called time base. And yes, you have to remember these two words. The vertical axis is called
please.
y gain, and the horizontal axis is called time base. Okay. So that's what happens for the CRO. কি বলছিলাম আমি এখানে কেন আসলাম আচ্ছা yes I was willing to discuss these graphs that we have over here. So I'm gonna finish discussing all these graphs over here, and then if you have any further question, I'll take your question. So if you have any question, please raise your hand. I would not like to take in between questions because that actually distracts quite a good number of people in many cases. So the first thing that we need to understand that the first row that shows that input at the y-axis, gain, and then time base off. Now, a couple of things we really need to consider, which is that if we give, I mean, whatever the physical input or physical measurement that you want to do using the CRO device, that thing will always have to be connected with the y gain axis or the vertical axis. So have a look at the lecture video once again. You can see that at the bottom part here we have two connection lines. Do you see that? You should be seeing this. These two connection lines are basically the input to the cathode ray oscilloscope device. So external input is always provided on the y gains. So and y gain is marked in volts per centimeter. Y gain is marked, I mean, or if you think for the scale for each of the axis, the vertical axis has the scale of volts per centimeter, and the horizontal axis has a scale of typically milliseconds per centimeter, or sometimes it can be 0.1 second as well. It can vary, but typical measurement হচ্ছে 85:1. বুঝাচ্ছি কি বলছি? Hold on. I think so. Asha. So the input has to be put onto the y-axis, and then we can choose how big each of the division on each of the scale will be by turning the knob or on the y-axis value or on the time base axis. Have a look at the lecture video. Have a look over in this video. You can see that for this figure that I'm sharing with you, which is from an earlier question of paper 4, you can see it very well that the y input was set to a very specific scale value, which happens to be in this case by observing the knob position is 5 volt per division or 5 volts per centimeter. So it's voltage per division, yeah. So 5 volts per division. So that's how they set up the cathode oscilloscope by calculation and calibration both. If you look at the time base, the person can essentially set the time base in a lot of different positions. We're gonna see about that for the later values of this table. But in this case, the time base is selected or it placed at 2 milliseconds per division, which means whenever 2 milliseconds is chosen, each individual division of the time axis will cost you furniture. Did I just say furniture? I think so. Okay, I didn't mean it. So time base will essentially help you to scale out the graph on the horizontal axis. So if I just go for a quick understanding that the way any physical graph works is that if you take your standard higher, standard means if you take a bigger amount of data for every division, which means if the value of your each division is bigger, for example, let's say 10 volts per centimeter is essentially a smaller scale compared to 40 milliseconds per centimeter. But what you need to understand that whenever the time period is getting bigger, essentially it means the wave is becoming slower. So that is one important bit. Why am I telling you all this stuff? Because I need you to appreciate that when for any graph, whenever we choose a higher or a larger scale value, the graph itself tends to become squashed or become smaller, and vice versa. So if you choose a smaller scale value, your graph will naturally be pretty large and wide. So that's that. So এখানে আমরা এই টেবিলের ফিগারগুলো খেয়াল করি, then I'm going to show you something else as well. So the first line shows us no input, so which is good. Why is it important to have the no run code in first class or scan? The reason is because this is one of the very few figures where Mr. Ronald did so the no input means that this is the case where both the y gain or the time base are not subjected to any external sequence. So whatever the situation of the bank, whatever the what I would say. So whenever the electrons will start their journey, they will not be affected by any of the pair of the plates. So X plate or Y plate, none of them will actually bend or apply any force on the electron beam. As a result, ultimately or altogether, that electron beam is gonna get to the L. So these electron beams are actually getting and falling at the center of the screen. So that is supposed to be the default behavior for any CRO. That once you recalibrate this thing, these two sharp locations, they will essentially be represent 0 for both the axes, and you will have this kind of a graph. The next point that we have is 1.5 volt cell. Having a 1.5 volt cell means that we have connected a 1.5 volt cell according to two ends of a voltmeter, which we should be able to calculate the resistor for. But we did stop it immediately as well. So if we set up a 1.5 volt cell onto the as the Y gain input, 1.5 volt cell will produce a 1.5 volt worth of direction or smoke. So because it is a cell which is a DC source, so the beam would never, to be honest, would never try to go across a vertical what can I say, a vertical sorry, not vertical, we can say that applying the let me just rephrase that sentence. By applying the 1.5 volt DC voltage, which is a DC voltage because it's a voltage of a cell, it has to be DC supply. So apply the two last declam, and whenever we'll apply a 1.5 volt cell, this will cause the trace to simply go up by 1.5 amount, and it will remain there. That is the amazing part, that if we do not apply the Y gain, if the trace is not moving from left to right, or from left to right, it always happens to move from left to right. If we do not have that component, all the other sequential movies of this component, they will actually do good. So 1.5 volt cell with a division of gain value of 0.5 volt per division per 0.5 volt per division. So we should be able to see our listener at the third location. So that is actually available on the CRO chapter. The third row tells us that minus 2.0 volts reversed. Now the gain has been halved compared to the earlier case. Now have a look. If you wonder that why would we, what would be the implication of the symbol minus 2.0 volts? What this symbol essentially means that if a positive voltage was corrected by factor, if the positive voltage moves the electron beam trace in the upward direction, then the negative beam trace is going to also move it in the downward direction, and the math simply works. Can you guess why the math works? I'll tell you. The reason why the math works is because 1.5 volt cell with 0.5 volt deviation, 0.5 volt per deviation causes the beams to rise earlier. Okay. দাঁড়াও, বলুন 1 মিনিট আসতেছি আমি। So the implication of the minus 2.4 voltage minus is that the trace should be placed to the lower side of the screen. Now, I've been talking about only about the third column of so far. I was not talking about the fourth column. At this point, I'd like to talk about the fourth column. So have a look at the heading differences. The third column heading is time base off, and the fourth column heading is time base on. What this essentially mean, whenever you will have the time base off, the beam would not move left or right. It will only move up and down by the effect of what you are feeding through these external wires or external connections onto the for the change of the y-axis. Whenever you turn the time base on, then your beam would naturally start to move from left to right, but that will not be controlled by an external factor. That will be only controlled by you, so that you can choose how fast the beam is gonna cover from left to right, or in other words, you can choose the exact time requirement for the beam to cover the distance through the screen, which changes by the sawtooth voltage. We discussed about the idea of sawtooth voltage in an earlier lecture, so I'm not going to get into that right now. So whenever you turn on the time base, the beam is simply going to move from left to right, and it's going to illuminate up the whole screen. So that's why for the first row, whenever there was no input, I mean nothing, no physical input were provided, which means the Y gain was not connected to the Y plates were not connected to any of the external signal. In that case, when the time base was off, we only were seeing a single dot at the center of the grid. But whenever we make the time base on, then that single dot becomes a line, horizontal line at that position. Similarly for 1.55 volt cell, and similarly for minus 2.0 volt cell. So we have lines in places of dots. Plus means the positive axis, and negative means the and minus means the negative axis. Now, in this case, if we go further, the fourth row that we have is 50 hertz AC with a peak voltage of 20 volt. 50 hertz AC with a peak voltage of 20 volt, where the gain is chosen to be 50 volt per division. So, because if you ever have to confusion about what the gain is about, you can always look at the unit, voltage per division. That unit belongs to which axis, y-axis or x-axis? Voltage per division essentially works for the y-axis. So in this case, it was given as voltage per division because it's easier for you to count the division. In many cases for the CRO, this can be also written as volts per centimeter. That also will serve your purpose by all means. So in this case, the gain essentially means the scale value for the y-axis. So if we have a 5 volt per division measurement to represent a total voltage of 20 volt, which is the peak voltage of 20 volt, the amplitude of your sine curve, if it which is supposed to be sine curve, that is supposed to be 4 divisions. And because it's an AC supply, and the peak voltage 20 volt means that peak voltage 20 volt means that the value of the voltage starts from 0, it goes up to plus 20, then becomes 0, and then goes down to minus 20 volt, and then goes up to 0 once again, which we can very easily achieve by controlling the voltage across the control plates, which are the Y plates. So in this case, whenever we have only the time base off on the third row, we are only having a vertical line, because this vertical line movement was provided or was fed into the CRO information because of the change of the main signal, or because the signal itself was an AC supply. That's why it was going in the positive axis, in the negative axis, and so on and so forth. পরে বলবো আমি আচ্ছা, and then when we are turning on the time base, we can see that this entire thing is now showing up as a sine curve, because what is happening, the external variation of the signal, which is the AC supply, that is gonna cause the trace to move up and down. And because now we have turned on the time base on, So from the internal voltage structure of provided from inside the CRO, this is going to start moving the CRO screen left or right with proper location. So if we can merge up these two information in single format, what we get is that the trace is going to move up and down as is going to move from right to left. So altogether you get a smooth curve which is shown on the 5th column. So that's possible over there. Now, one of the things that I would like to tell you attention to is that here they have not at all mentioned about the time base, that what is the time base of this thing. They have only mentioned that this AC supply has a frequency of 50 hertz. Now, I'm gonna put your UQs at option 2 so that you can unmute yourself and try to respond to questions that I ask you. And I'll take creative questions after a while. So one of your friend Ferdinand has asked a question privately. Preferably don't ask me questions privately in the group chat. I really appreciate that. The question he asked me is that, so peak voltage bolte maximum and minimum value bujhai. The answer is yes, and that is for an AC supply. AC supply maximum and minimum value bolte amra peak voltage bujhai. The answer is yes. Acha. Kids, the reason I need your help with, can someone tell me what is the time-based value? Time-based value will come in millisecond per division. What is the time-based value for the 4th row? Which is the time base is not given in the question. That's why I'm asking you.
20 milliseconds.
Okay, I really don't remember. One of your classmates just demanded 20 milliseconds. Rest of you?
Sir, কোন column? 4th column নাকি 3rd column? আর কোন row? Sir?
You have to observe the 4th column, and I want you to try and calculate the time-based setting of this graph, which is not given in the
all of the graphs or one of the rows? 3rd row,
4th row.
5 milliseconds. 5 milliseconds per division. 20.
Sir, 1 second নাকি?
20 milliseconds.
1 second per division.
না স্যার পুরোটা 1 সেকেন্ড মনে হয় না
4
So
milliseconds.
I need you to tell me how much is the time base, which means this should come up
5
as
milliseconds.
some amount of time per division.
milliseconds per division. So এখানে 1/50 করলে আমরা সেকেন্ডের টাইম
কিন্তু তোমার কথা শোনা যাচ্ছে না, মাইক্রোফোনের কাছে এসে কথা বলো।
সেখানে
T equals to 1/4 হয়ে যাবে।
1/t দেখো 1/f করলে হয় না, আমরা 1/50 করলে 0.02 সেকেন্ড পাবো, এটাকে মিলিসেকেন্ডে কনভার্ট করলে 20 মিলিসেকেন্ড পাবো।
তারপর 0.02/4
হ্যাঁ স্যার, তো 4 দিয়ে ডিভাইড করে দিব, শেষ।
তাহলে
5
5
মিলিসেকেন্ড
milliseconds
5 মিলিসেকেন্ড পার ডিভিশন।
Yeah, what Abdullah just said is absolutely correct. For those of you who did understand what he said, well and good. For those who did not understand what he just said, I'll help you to understand this thing. What I'm asking you is to find out the scale value of the horizontal scale, or I asked you to find out the time-based value for this graph, which is not given in this graph. That information is not available in this table anywhere, because on the second column we only have the gain value in terms of the y-axis. Now have a look. For the 4th row, the provided voltage or the input voltage that we are trying to analyze is in the CRO, and this one has a frequency of 50 hertz. So from 50 hertz, you can very easily first calculate the time period of the signal. That time period should be 1/50, which is 0.20 second. If you multiply that into a millisecond, this will become 20 millisecond. দেখা বোঝা যাচ্ছে কিনা? বলবান বোঝা যাচ্ছে?
স্যার আরেকবার বুঝুন।
I want you to calculate either by writing, I'm not going to write this, either by writing or in your head, what would be the time period for a signal which has a frequency of 50 hertz. Help yourself.
1/50 seconds.
কত?
1/50 seconds.
Yeah, I wanted to give me that number in milliseconds.
That 20 milliseconds.
Yeah, 20 milliseconds is a correct response. But do all of you agree with this one?
Yes, sir. Yes, sir.
Okay. So one cycle or time period is 20 milliseconds means that for one complete cycle, the required amount of time is going to be 20 milliseconds. Now have a look on the fourth column and have a look at one full cycle. What you will be seeing that on the fourth column, using the red lines, we have two complete cycle. How many full sine curve do you see? You can see two repetitive structure. Do you see that?
Yes, sir.
Original left একটা right একটা তার মানে হচ্ছে এখানে আমাদের in this case for this figure the time period is represented by horizontally by how many divisions? How many horizontal divisions represents the time period?
For the figure on the screen.
For the figure available on the fourth column, fourth row.
Sir,
How
8.
many horizontal divisions make up one time period?
Sir, 4.
4 is a correct response. Do all of you see that in this cycle, four horizontal divisions make up one complete cycle? You should be able to see that. So why is that important? Because here 4 divisions should represent exactly 20 milliseconds, which is the time period that we just calculated from the numerical value that is given. So 20 millisecond is equivalent to 4 divisions. So 1 division should be equals to 5 milliseconds. So I can say by calculation that the time base setting for this fourth row when the time base was on was 5 millisecond per division, because exclusively 5 millisecond per division would give us this shape. এই পর্যন্ত বুঝা গেছে কিনা সবার?
Yes, sir.
রেসপন্ড করো।
Yes, sir.
This is just basic graph calculation, but that calculation can go in both way. Sometimes you have to calculate the scale value using the information, which I just did right now. Sometimes you have to be able to calculate the graph locations using the scale values, which is going to show up in a lot of cases for the MCQs. But bottom line, as long as you understand what you're doing, you should be able to do this pretty well. Now have a look at the fifth column. Read the fifth column. So fifth row, 25 hertz AC, and try to decipher the information over here. If you have any question, you ask me. I want you to give it a try on your own.
Time period কি 8?
The time period 5.
Okay. Then 40 milliseconds.
5 what?
Oh, sorry, sir. Time period হচ্ছে 40 milliseconds.
Yes, sir.
Okay.
আমি বলেছিলাম যে 5 milliseconds per division. I misunderstood the question.
Sounds nice. It's good. So 5 millisecond per division is the time base value, and do you understand the meaning of the graph over here, everyone?
Yes, sir. One oscillation is produced in 40 milliseconds.
Good. So what you should be also see, you should also be able to see is that whenever you have the time base turned on, the entire trace starts to move from left to right. I mean exclusively left to right. The trace would not move back and forth in both directions, because the way the trace move along the x-axis or the horizontal axis, that it sweeps from one end to other end, then it jumps back to the starting end. Then it sweeps through the from left to right, and then it jumps from right to left. So that's one of the property of this thing, that how it works. Now, important bit that I want to tell you, that if you have a look at all the graphs, if you make all the fourth column graphs squashed on the y-axis, only the red lines, if these red lines were perfectly squashed onto the y-axis, you would get the exact graph which is time based off. Do you see that? What I mean is that মনে করলে ফার্স্ট আমাদের একদম ফার্স্ট হতে আসছে নো ইনপুট যখন টাইম বেস অফ এর অফ কন্ডিশন থাকা অবস্থায় আমাদের রিং ডাস্টার হচ্ছে এক্সিটি জিরোতে, মানে এরপরটাতে আমরা টাইম বেসটাকে যখন অন করছি দ্যাট সিম্পল হরাইজন্টাল লাইন, that simple zero voltage line actually became a that simple zero voltage point becomes a horizontal line, which means if we could squash time and eventually merge all the points of that line into one single point, that would very much look like my third column. Do I make sense?
Yes, sir.
এই কথাটা কেন বলতেছি, I'm telling you this to make you convinced about the fact that it is the purpose of the time axis to extrude or to elaborate the graph along the x-axis, along the x-axis. So why is this important? Because to represent a wave properly for its purpose and everything, it's important that we understand what the individual axis system does. In this case, the vertical axis essentially deal with the magnitude of the voltage, and the horizontal axis essentially deals with the time period of the voltage supplied. So if we don't have an AC supply, we're simply going to have that simple trace moving left and right, left and right, left and right. But if we do have an AC supply available, then there'll be simultaneous movement on the trace, or trace means the electron beam, from the X plates and also from the Y plates. That together movement is going to make these beautiful curved shapes, so that your trace will be affected by both the plates simultaneously. বুঝতে পারছি কি?
Yes, sir. Sir, horizontal movement direction to X plates they influenced হয়, right?
Yes.
Sir, squashing এর ওই পার্টটা একটু রিপিট করতে পারবেন প্লিজ?
No. Squashing এর পার্টটা হচ্ছে if the electron beam did not move along the x-axis, it would only move up and down. That information could also be obtained by placing all the individual y-axis values at x equals to 0, which means on the y-axis, from all of the individual positions. Or something that I mean like this. Board একটু ইয়াতে দেখো যে কি বলে ভিডিও ফিডে দেখো. Let's say if we have our axis system that looks like this, and let's say we have a graph, pretty smooth curve, red, that looks like this. Perfectly হলো না, but assume I'm correct. So if this is a graph of a certain object or certain object, I can, if I only represent all of the variations of the variable that you're trying to plot, x-axis variable, y-axis variable. If this is the subscope variable, then it might actually come across some significant damage as it eventually lands on its as it eventually finishes the cycle. So the point I'm trying to transfer in your head is that if I take this graph and squish it onto its own self, what are you going to get? Have a look.
The line X is equal to 0, otherwise the y-axis.
Exactly, that's what I meant. The time base off means that the upward and downward movement is possible. That is not unrestricted or unobstructed. However, there is one factor that is perfectly restricted. That is the x-axis movement of the beam. এই পর্যন্ত বুঝা গেছে কি বলবান এই টেবিলটা?
স্যার আই হ্যাভ আ কোশ্চেন।
হ্যাঁ বলো।
আমরা যে এক্সটার্নাল ইনপুট গুলো কানেক্ট করব না, ওগুলা কি V3 আর V4 এর সাথে কানেক্ট করব?
ইয়েস, না V3 আর V4 এর সাথে কানেক্ট করবো না, শুধু V4 এর সাথে কানেক্ট করবো। Because have a look, the external inputs are exclusively given to which component?
ও ইয়েস ইয়েস আচ্ছা আচ্ছা আচ্ছা।
এক্সটার্নাল কম্পোনেন্টটা শুধুমাত্র আমরা কানেক্ট করবো হচ্ছে V4 এর সাথে। V3 would be operated or V3 would be fed its voltage from the internal circuitry of the cathode oscilloscope device. মানে automatically defined আর কি by the choice of your knob position.
And when we set the time base to say 5 milliseconds, the voltage will be supplied to the X plate in such a way that each division on the trace represents 5 milliseconds, right?
Alright, বললাম পেজ উল্টাও, এখানে আমাদের দুটো ইউজ দেওয়া আছে, এই ইউজ দুটো একটু পড়ো, তারপর আমি তোমাদেরকে আর ফার্দার গ্রাফ দেখাচ্ছি। এই ইউজ দুটো একটু পড়ো এভরিওয়ান। On page number 384. পড়া হলে বলো যে স্যার হয়েছে।
স্যার স্যার সাউন্ড ওয়েভের এই সাইন কাপ প্রডিউস করার জন্য আগে আমাদেরকে মাইক্রোফোন কানেক্ট করতে হবে না?
হয়েছে স্যার ডান।
বুঝি নাই কি পর্যন্ত কিসের কথা?
সাউন্ডের মানে সাইন মানে কাপ প্রডিউস করার জন্য আমাদের তো মাইক্রোফোনের সাথে আগে কানেক্ট করতে হবে। ও সিআরও কে।
CRO can only sense electrical signals. So whatever physical variable that you want to detect in your CRO, you have to give the correct type of translator medium. Yes, the answer to your question is yes.
স্যার এখানে আমরা টাইম বেস যখন সেট করি তখন টাইম বাই ডিভিশন হিসাবে থাকে। So how does that influence the V3 in the voltage in the X plate?
If you have a high voltage across the for the value of V3, then your beam would be attracted / repelled more strongly, and it's going to cover the horizontal axis really fast because the negative plate is pushing the particle really strongly, and the positive plate is also attracting it very not so strongly as well. So that's possible. However, তোমার কোশ্চেনের জন্য কিছু কোশ্চেন আবার বলতো।
স্যার কোয়েশ্চেনটা ছিল যে when we influence the time base, how does the voltage V3 in the X plate change to put our settings into action?
আচ্ছা বুঝছি। So that's that. So if you choose a smaller value of frequency, you're going to allow your device, I mean your ওয়ালের পিছনে থাকে এর নাম কি, so you can allow your CRO to perform the left to right movement. Now how much do I mean by left to right movement? In your book, if you just turn up one page earlier, and have a look at the figure 24.7 at 387. What do you see?
Sir, figure 24 point.
7.
Yes, sir.
So what does that figure mean?
For one cycle, t seconds is required.
And then what happens?
That cycle is repeated. Sir,
Sabir, I could not agree more, but I would like to add more to this information. What I would like to add is that this graph shows us that for one complete cycle, we require some time where the voltage change will happen gradually, and after it reaches the peak on one side, whether positive or negative appropriately, after dealing with the person, we can then continue moving forward. So what do I mean by this? What do I mean by this? What I mean is that so what do I mean by this? What I mean is that the time base is not controlled by the external output voltage. The external output voltage is only fed to the y-axis or the voltage plate that controls the thing. By choosing the value of the time base setting, you can actually apply how often or how frequently or by how magnitude the voltage value V3 will be affected. Now, if you choose a large time period, then the beam has to move from one end of your screen to the other end of the screen in quite a significant amount of time. But if you consider that, sorry, but if you do not have your time base on, I mean, if you have a smaller time base on, small time base means if your division representing is small, then the time base is going to cover the entire screen pretty fast. But if your time base value is large, then it is going to take significantly longer to consume that entire earth.
yes, sir. Basically, if we wanted to be switch it from 2 milliseconds to 1 milliseconds, we need essentially increase the voltage applied across the X plates to increase the speed at which the screen is covered, making the time taken less. Therefore, sir.
Yes, exactly.
Yes, sir. Understood.
Good. So yeah, that was a very good question. আচ্ছা, আমি আরেকটা গ্রাফ তোমাদেরকে একটু দেখাই, and then we might call it a day. 9:20 বাজতেছে। আরেকটা গ্রাফ যেটা দেখাবো সেটা হচ্ছে ওয়ার্কশিট থেকে দেখাই। ওয়ার্কশিট থেকে দেখাইলে এখানে আছে হচ্ছে बहलाता है খুঁজে পাই না কেন? কি যেন খুঁজতেছি বললাম? কি ব্যাপার, আমার কন্ট্রোল কিটা প্রেস করা ছাড়াই আমার মাউস ঘোরালে সব জুম ইন জুম আউট হচ্ছে কেন? মাউস ঘুরে তো উপর নিচে যাওয়ার কথা না? What is this?
Weird. আমি বারবার এই কোশ্চেনটা কি আটকে দিচ্ছি সিরিকুলাম মনে একটা কোশ্চেন আশা আটকে গেলাম আসলে মানে হলো না
স্যার আরো পড়াবেন?
এই গ্রাফটা একটু দেখাতে চাইছিলাম এই গ্রাফটা দেখাতে কি সময় কুলাবে না আমাদের
20 জন আছে।
আচ্ছা এই গ্রাফটা আমি নেক্সট দিন দেখাবো না ঠিক আছে তোমরা সিআরও পার্টটা বই থেকে একটু পড়বা সবাই ইউজেসের পার্টটা কি বোঝা গেছে সবার যে দুইটা ইউজ আছে এখানে আরো দু তিনটা ইউজ আছে যেটা আমরা ওয়ার্কশিট করার সময় দেখবো মার্চ 3 বা এক্সাম রিপোর্টে আসবে বাট এখানে যে দুইটা ইউজ দেখতে বলছিলাম এই দুটো ইউজ কি বোঝা গেছে আচ্ছা বুঝা না গেলে নেক্সট ক্লাসে মনে করো we're going to continue about the CRO lecture from this point onwards next class CRO টা ভালো করে বুঝালে তাহলে তোমাদের আর ওই ওয়েবসাইট কোর ওয়ার্কশিট গুলোর প্রবলেম করতে আর আটকাইতে হবে না kids thank you very much
Bye bye, sir.